Hello, in this video I'm going to be adding more features to my gravity game. I'll have a link to my last video on it in the description. You can also try it out at pigsquiggle.netlify.app, also linked in the description. The main thing I want to add in this video are new planet shapes. I already have different types of planets like destructive, unstable, and explosive, but all of my planets are plain circles, and that is boring. The first shape that I will attempt is an idea my brother came up with, a ring planet. Ring planets will just be a ring with a hole in the center. This means you can easily make containers for other planets without having to do this. You will be able to put other planets inside of it and also have planets on the outside collide with it. I think this will make things a lot easier to build. The other shape, or many shapes, that I want to make is a fused planet. What I'm planning is that there will be an option to turn the current planet into a fusible planet. Normally when you place a planet overlapping another planet, they will push apart and shoot away from each other. But if you have the fusible option on, when you place two planets overlapping, they will fuse. This means they will stick together, which will let you make many different shapes of planets. The fused planets will all move in unison and will kind of act as one big planet. I'm not sure if I'll be able to make this, but I'll try to. The last thing I want to add isn't related to planet shapes. What I want to do is make more realistic collisions. Right now I have some very redundant code that basically does the same thing 3 times. One section is for if a heavy planet touches a light planet, one section is for if a light planet touches a heavy planet, and one section is for if 2 equally massed planets touch each other. The way I have it right now is that when a heavier planet touches a light planet, it will not get slowed down at all and will completely push the lighter planet. This is a problem because if 2 planets collide and one is very slightly heavier than the other, the heavier one will have no resistance and will completely push the lighter one. What I want to add is to make it so the resistance is proportional to the ratio of both planets' masses. This will make it so that if a planet with 2 times the mass of another planet collides with the other planet, the heavier planet will push the lighter planet twice as easily. Now I can finally start coding. First, I think I'm going to work on the better collisions, because both of the shapes have something to do with collisions, so I don't want to have to deal with those while fixing it. What I'm thinking is that I can kill 2 birds with 1 stone by adding the proportional pushing, which will fix that problem and also shorten those 3 big code blocks into just 1. So the way I will fix the collisions is to make it so when 2 planets collide, it gets the percentages of their proportional masses and moves them apart relative to that. If there are 2 equally massed planets, I want them to both move apart 50% of the total distance both of them need to move. That means I need to add their masses and then get the percentage of each one by doing their mass divided by the total mass. Then I'll multiply the total move distance by the percentage of each planet and use it for the other planet. Because if one has more mass, it would get the bigger percent, but the one with less mass should move more because it's smaller, so we have to switch the percents. Another example is, let's say one planet has a mass of 50 and the other has a mass of 100. I want the one with 50 to move 2/3 of the way and the one with 100 to move 1/3 of the way. Because 50 plus 100 equals 150, and 50 divided by 150 equals 33%-ish, while 100 divided by 150 equals 66%-ish. Now it's really time to code the collisions. Time for the coding dance! So after a few bugs, I finished the better collisions. There are still some bugs, but they are very minor, and I don't think they'll be too much of a problem. Now if you place a big planet and a small planet overlapping, the big planet will also get pushed a little bit. This means many small planets can now overpower one big planet instead of the big one just powering through. Also, the collision code changed from this to this. This change now makes my code a lot easier to navigate, which will help me make the next shapes. Speaking of the next shapes, it's time to make the next shape. I think I will start with the ring planet. The way it will work is if a planet is past the center of the ring, it will collide by bouncing inward into the ring. But if it's on the outside, it will collide normally. To do this, I just need to modify the code to do those things based on the distance the planet is from the center of the ring. Time to code it. There's no coding dance this time because I got a comment saying I should include time lapses between coding, which is a good idea. So time lapse time. finished and I'm really happy with the result. There are a few bugs, but they're funny, so I don't care. The main bug is that on the ring planets, since I made the textures in a weird way, the outlines of some of the shapes are black. This is a little weird, but I want to get on with the video, so I'll fix that another time. Other than that, the rings are really fun to play around with, and they can do some pretty cool things. I made it so that rings don't have any attraction to the planets inside of them, and vice versa. Without this, planets will just clump up in the center of the ring, and that's boring. The width of the ring itself is also proportional to its radius. So small rings will have less wide rings than bigger rings. This is because I made the planets their own textures instead of just cutting a hole in the middle of the planet with code. Now I think the last thing to do is to make the fusible planets. I think the way it'll work is if a planet is fusible, it will have a list of all the other planets that it is fused with. It won't collide with those planets and also won't get pushed by them, so they will act as one big planet. They will also share velocity and get pushed back as a whole when colliding. I'll also try to make the collisions based on the mass of all the planets, not just the one colliding, but I'll see what works. Time to code it. Alright, coding dance it is. This step took a really long time. There were a lot of difficult bugs that I had to fix while making this, and I procrastinated a lot, but finally I'm finished. There are still a few bugs that could be issues later, and some bugs that were patched in inefficient ways, but I don't really care anymore, because this project is annoying me. Now you can make fused globs of planets that float around together and move as one. You can even combine ring planets and normal planets. This is pretty fun and lets you do a lot of things. The one main bug that still exists is that sometimes when you try to fuse a separate fusible planet with an already fused glob, it kind of floats away, but this isn't a huge issue, so I'm pretty happy with the result. One of the bugs that I faced when making this was related to removing fused planets. First, when you tried to remove one, it would freeze and give you an error. This is because all fusible planets have a list of the indexes of all the other planets they are fused with. When you remove a planet, all of the other planets it was fused with can't find its index, so it gives an error. This seemed like a simple problem at first, but I ended up trying 4 different ways to fix it, and none of them worked. After a long time, I realized a mistake I had made. When the planet got removed, I imagined that its index was being removed from the list, but what actually happens is that its index does get removed, but the planets with higher indexes move back to fill in its place and take its index. This means when I was removing a planet, the planets it was fused with would think that another planet was the one they were fused with, and it would start glitching. The way I fixed this was by instead of completely removing the planet, I just move it infinitely far away and set its mass to 0, so that it still takes up its place in the list, but it is virtually removed from the game. This was a really simple issue, but it took me a while to realize, and this is just one of the many bugs I encountered. I think this video was one of the most difficult coding videos that I've done so far, and I glossed over many of the in-between bugs that took me a long time, so if you enjoyed, please subscribe. It gives me the motivation to work on more videos, and I have some ideas about what I will work on next. I'm thinking I will either work on a powder physics system that I started last summer, or I will start a new 3D renderer, so you're welcome to vote which one you want to see in the comments. Also, sorry I didn't post in a while. I was going to work on a multiplayer game, but I realized that was out of my level, so I thought I might do that in the future when I have a deeper understanding of it. Thanks for watching, and I'll see you in the next video, which will not have anything to do with this project. Bye!